Welcome back to C# for Total Noobs. In this lesson we'll talk about inheritance and access modifiers. So we still stick around classes so that you can make an impression about how important classes are in C# and in object-oriented programming. Furthermore, this lesson is very important because with inheritance and access modifiers, we already described two of the main principles of object-oriented programming, which are inheritance and encapsulation. Encapsulation because access modifiers are used in C# to achieve encapsulation. Before we dive, however, deeper into inheritance and access modifiers, I just want to know that during this training course, we really won't dive deeper into the principles of object-oriented programming. However, there will be another course which is a direct sequence of this C# for Total Noobs training course, in which we'll talk plenty about principles of object-oriented programming and how these principles are used or implemented in C#. Now let's get started with inheritance, and of course we ask ourselves, what is inheritance? Thinking about a definition, we could say that inheritance enables you to create new classes that reuse, extend and modify the behavior that is defined in other classes. I am sure that this might sound a little bit too theoretical for you at the beginning, but I think there is also a real-life example that we can use to describe a little bit how inheritance works. When a new child is born, we often say that it has the eyes of its mother's, or it has the nose of its father's, and so on. This means, of course, that the child inherits some traits, some characteristics from his parents. But of course, the child has some traits and characteristics that are not common with his parents. So they are their own traits and characteristics. And that's exactly how inheritance also works in C#. We have a class and then we have a new class that can inherit from the other class, but it doesn't have to inherit or to use or to implement all the features or all the traits, all the characteristics that are inherited. So that's exactly how inheritance also works in C#. Now, inheritance, we would also like to describe few principles around it. And normally the class whose members are inherited is called the base class. This is important to note, this concept, this keyword is base class. And the class that inherits those members is called the derived class. And from now on we'll often refer to base class and to derived class. And know that each time we refer to base class, we basically think about the class from which other classes have inherited something. And when we talk about a derived class, we talk about a class that inherited something from another class. Now, a derived class can have only one direct base class. This means that a class cannot inherit at the same time from several different classes. However, inheritance is transitive. So this means that if class C, for instance, is derived from class B, and class B is derived from class A, class C inherits the members declared in class B and also in class A, because as said, inheritance is transitive. And I think on the next slide we will also see a graphical representation about how this works. A next very important thing is that when you define a class to derive from another class, the derived class implicitly gains all the members of the base class except for its constructors. So this is very, very important. A class can inherit from another class things like properties, things like methods, but it cannot inherit constructors. And therefore the derived class can basically create its own constructors. Also, the derived class can reuse the code in the base class without having to re-implement it. And when we'll go to the practical part, I think we will see exactly how this works and things would become much clearer for you at that point. And here is the example that I mentioned earlier. Let's assume, for instance, that we have a class object and we have it here on the left of our screen. Now, this class object has 7 members, like equals, finalizer, get hash code, and so on. Now, if we have another class that is called work item that inherits from object, it will inherit all the seven it will inherit all the seven members that the object has, but it can also implement few other members. And in this case, work item inherits from object all the seven members and adds other five members to it. So in total, this class work item will have 12 members. If we go then one step further and we have another class called change request that inherits from work item, this means that change request will inherit from work item all the 12 members, so including the 7 that come from the class object, and it will add another 2 members, 2 own members to this class change request. So this means that at the end, change request will have a total of 14 members. So this is really how transitivity in inheritance works. Even if this change request class didn't inherit directly the class object, it still has access to all the members of object because it inherits work item, which also inherits object. So this change request class will have all the 12 members that the object and work item classes have combined. A next good question is, why would we use inheritance? Well, you could use inheritance when you have a certain type of hierarchy in C#, and you can implement or represent this hierarchy as is a relationship and not has a relationship. So we can say, for instance, that dog is an animal. And in this case, we could have a class dog that inherits from a class animal. And in this case, we can also implement this type of hierarchy to know exactly, let's say, which class is let's say, the base class for all derived classes. You can also use inheritance to reuse code from the base classes. And this might be very important. Right now, when we do not write very, very large programs, things might not seem that important, but when you have really huge program, reusing code is really, really very important. Because instead of rewriting 100 lines of code, you can simply use inheritance, and you already can put those 100 lines of work you can put those 100 lines at work for you without the need to write them again. So this makes the code much cleaner and also spares you a lot of time. Also, if you need to apply the same class methods to different data types. And we'll see during the practical part also some examples on how to do that. And another good reason why we would use inheritance is, for instance, when you want to make global changes that derive classes by changing a base class. And this is really, really important, because let's assume maybe that you have a certain class, or let's maybe think that we have a class student, that we have a class teacher, or that we have another class administrator, and we could give also other examples. And each of these classes might have a first name and a last name. And let's assume at a certain point that, well, we want to change the first name in last name, and let's say to change the capital letters. In this case, we would have to go in each class and make these changes. Imagine if you have 100 different classes that implement this first name and last name, and we want to implement these changes. We would have to remember exactly all places in code where we have done this, and of course we would have to change it. But for instance, if you use inheritance and if we have a base class that contains a first name and a last name, if we want to change anything, we can change something in the base class, and then all the changes would be automatically reflected also in the derived classes. So this might be also a very good reason to use inheritance. Let's go now one step further to accessibility modifiers or access modifiers. And these are really important also in conjunction with inheritance. And we'll see exactly why. But before that, let's try to define a little bit what these accessibility modifiers are. So access modifiers are keywords used to specify the declared accessibility of a member or a type. And remember, when we declare or when we wrote our classes, we made them usually public. But there are also other keywords, and these keywords might define exactly if members or how members are available to be inherited, for instance. In C# we have 4 keywords that reflect this type of restriction or access modifiers. We have the public, protected, internal, and private. We'll look into what exactly each keyword means or does just in a few seconds. But before that, we have to be aware that even if we have only 4 keywords, we have in total 6 accessibility levels in C#. Why this happens? Because 2 of them are combined by using 2 of the keywords that we mentioned earlier. So the first one is public, and in this case the access is not restricted. For instance, all class members that are public can be inherited anywhere in the program that you write, so basically without any restriction. Protected instead defines an access that is limited to the containing class or the types derived from a containing class. And we see that here in protected, this is, I would say, very specific for inheritance. And I think you would get a much better idea when we will go to the practical part. Internal, this means that access is limited to the current assembly. This is really important because in our case we always used only one project. As said in the first lesson, when we compile a project, it results in an assembly. That could be either an exe file or a DLL file. Now, in a larger program, we might have different projects. And this would mean that when we compile the entire program, it would have different assemblies. So let's assume that we have a project A, and if we declare some class members there with this keyword internal, if we have a project B and we want to reuse that specific class member in project B, we won't be able to do that. A next access modifier is protected internal. And in this case, access is limited to the current assembly or types derived from the containing class. So basically, it's a combination between protected and internal. And a next keyword is that private, and in that case, access is limited only to the containing type. And private protected, in this case, access is limited to the containing class or types derived from the containing class within the current assembly. Now, private protected is a fairly new access modifier starting with C# 7.2. It was previously not there. Also, from my point of view, right at the start of your journey to become a .NET developer, it's important to know exactly that these keywords or these access modifiers are used to restrict access to different members. Could be class members, could be properties, could be fields, and so on. It's not important to know exactly, for instance, this private protected is something that is really not very often used, but at least public, protected, internal, and private are the keywords that are really fundamental, and I will strongly encourage you to learn this definition and exactly what the access level for each of these keywords is. And as said, things might get a little bit more clearer once we will get into the practical part and we will see exactly how access modifiers work. Therefore, let's switch over to Visual Studio so that we can get our hands dirty with a little bit of code. What we want to do right now is to play around with geometrical shapes, just like we did in school earlier in our lives. So we'll also revisit few concepts that we studied during the geometry classes in school. I can promise you it won't get very complicated. Let's get started, however, and what I want to do is to create a new class right now. To do that, we will simply right-click the project and then click here Add. Of course, we can then choose Class here. A new dialog window will open where we can specify the name of our class, so how also the class will be called, but also the file that will be generated. Let's call this shape.cs. This will be a more generic class called shape. First of all, let's make this class public, and I promise you we'll come a little bit closer, or we will study a little bit deeper what these access modifiers do once we get there. For now, let's concentrate on this class shape. What I want to do here is very simple, create this class with a very few properties. One of the properties would be the width and the other property would be the height. Let's then get started with be public. We will make everything public for now, and then we will change these keywords to see exactly what happens in our code. This would be an integer, would be the width, and get set. As said, this is the way we declare properties in classes. Let's also have a new property. This one would be called simply, it will also return an integer, and it would be called height. Also get set to have a new property. What I would like to do right now is also to have a default constructor. Let's have it. It would be blank, so nothing would happen here for now. Of course, if you would like, we can also skip the constructor, because as said during the lesson when we studied classes, each class has a default constructor, except you specify another one that takes in some arguments. For now, let's keep it like this, and we won't write here anything for now. Here, of course, we have missed a semicolon. Now everything should be right. One other thing that I want to do here is simply create also a method. Let's make it public. It would return a double in this case. This method would be getArea. Of course, what we would like to do with this method is to calculate the area of the shape. And how is this area calculated right now? Well, of course, we could do it with width multiplied by height. So let's return width and multiply it by height. This would then return right now the area of this shape. Let's go now back to this program.cs file, and we can already create a new shape. So it would be shape, let's call it S1, it would be new shape. Also, it would be nice to give some properties for the width and height. So here's the height. We can make this 5. It could be centimeters, millimeters, meters. It really doesn't matter right now. Then we can also specify the width. This width should be 10. So it would be easier to calculate. What we can do right now is then print this to the console. So console writeLine. What we can do here, we will also use string interpolation like we did very often in our lessons. Let's also switch the language for my keyboard. Okay, here the shape area is, and we simply can put here s1 dot get area. You can see that we have this method here. Of course, I also had a typo there. So let's correct this. It would be get area, of course. Let's go also back to the shape, and it would be get area. Now it should be correct. So we switch back to program.cs. Right now what I would expect is that when we run this program, it would print the area of this shape to the console. So let's run it and check if this happens. It would take, of course, a few seconds. And then here the shape area is 50, which is correct because I have specified a width and a height. And then, of course, I have returned this method, which is simply the width multiplied by the height. So everything is straightforward right now. Let's go one step further, because in our life we don't have this generic concept of shape. We know about rectangles, squares, triangles, circles, and of course more complex geometric shapes. Let's try to reproduce this in our code. To do this, we will create a new class. So right-click the project, add class. Here we can specify the new class. I want to create a rectangle class. So it would be rectangle.cs, which should be okay. Now we have the new class. Let's make it public. As I said, for now we have all things public here. And if we think a little bit about here, our rectangle has a width and has a height. And if we want to calculate the area of the rectangle, it would be exactly the same. So we see here that we would have the property width on the rectangle class, the property height, and we would also have this method getArea. So in order to avoid writing this code again, what we can do here is simply make rectangle inherit from shape. And in C# you instruct a class to inherit from another class by using colon. So this type of notation, this type of syntax means that a rectangle inherits from shape, which is fairly straightforward. As we know from the theory, it doesn't inherit the constructor, so what we can do here instead, put a new constructor for this rectangle. And why I would like to do this is because when we create a new instance of rectangle, what I would like to do is already pass a width and a height, so that nobody is able to create a new object of type rectangle without providing this information. Because without this information, this class cannot work properly. So let's get here one step further. This means that in our constructor what we would need is an integer for width and an integer for height. This means that each time somebody, or when we want in program.cs to create a new instance of this object, we will need to provide in the constructor an integer for width and an integer for height. What we can do, however, here in the constructor, and this becomes real interesting since we talk about inheritance, we haven't defined any property on the class rectangle itself, but if we want to set the width, the property width, we can do that. So we do this. This means that the property width would be equal with the width that we receive in the constructor. And similarly, we can do the same for height. So it would be height would be equal to the value that we get from the constructor. So notice that even if we didn't specify or define the properties width and height on this class rectangle, since this class inherits shape, it already has these properties, so no need from our side to do this again. So right now we could go back to program.cs. Let's try to find it. It would be here. And what we will do right now is we'll create a new rectangle. So rectangle, let's call it R1, would be new rectangle. And we have this red squiggly line here, of course, because in the constructor we need to provide an integer for height and an integer for width. So let's provide here 6 and 12, which would be fairly easy. The interesting thing that we can do right now is that we don't need to specify anything else. We can directly do a console write line. Also use string interpolation here because I think it's much easier like that. Here we can say the rectangle area is, here of course we have to specify is R1, and once again, even if we didn't specify a method for getArea, we already have this method here because it is inherited from the class shape. So this is very interesting. Of course, we need to put everything in parentheses, and right now our program should be able to also print the area of the rectangle. Let's check it out. Indeed, the rectangle area is 72, and I would assume that it is correct. Here, if we go back to this rectangle.cs, it's very interesting because since we inherited from shape, the only thing that we did on this class was setting the width and height in the constructor. So we were not obliged to do anything else. We didn't define any property. We didn't define the getArea method. We just construct an instance, and since it inherits from shape, then in rectangle we can simply calculate the area using the method that we have in shape. So this is fairly cool. But what happens next? Because right now what I think it would be useful is to also have a geometric shape called square. Now square is a very interesting one because we know that the width and the height are the same, so it's exactly the same value. In this case, of course, we don't need both of them. Let's create a new class. So right click the project, add new class. Of course, this class would be called square.cs. We will make it public as usual. And as promised, at the end of a lesson, we will play around with these accessibility modifiers. So we will see exactly what happens. Let's also provide here a constructor. What we want to do is to take here some values and to assign it to either height and or width. The cool thing about the square is because it really doesn't matter if we assign this value to the width or to the height, because these two values in case of a square should be equal. What we can do here is simply take an integer for width, for instance, and here we could simply do the following thing. Width, okay, of course we did not inherit, so we have to inherit from shape, as we also did earlier, and in this case we have the property width, which should be here. Of course, if I type it correctly, this time it should work, and this would be to what we receive from the constructor. So everything is fine right now. However, I have a problem right now, because if I want to create a new instance here, let's maybe try this out. So let's create a new square. It would be square sq1 would be new square. Let's provide here an integer which would be 7. So right now we have a new square. The problem is when we try to print this to the console right now, we will encounter some problems. Let's also use string interpolation here. The square area is, and what we can do here is sq1.getArea, because we have inherited this getArea method, and everything should be fine, except I made a typo here once again, so it's of course console write line. Now everything should be fine. So let's run this program. What happens here right now is that I would expect here to see this value of 0. So why did this happen? Because, well, we provided a value for the width, but still something doesn't add up. So what happens here is basically that if we go back to shape, we see that it calculates the area by multiplying width with height. But in case of the square, we do not simply have a height, we have only a width. So this is a little bit trickier right now. But we can also use inheritance to change behavior of the methods that we have inherited. Here, a good thing would be here to add another keyword, virtual. And you probably ask yourself, what does this mean? For now, we won't explain it. We will do something on the square class, and then we will come back to this virtual keyword that we use here. What we can do now in the square class, let's get back to the square class. So what we can do here is another method, which would be public override double getArea. What does this mean? And what we want to return is, of course, width multiplied by width. In this case, it should be work. So what have we done right now? Well, we have added this virtual keyword to the method on shape. This virtual keyword is very, very important because it instructs .NET that, hey, this method here can be changed by classes then inherit from shape. And the way we can change the method or the behavior, in this case we change the way we calculate the area, is simple, because what we do is just use this keyword override. So what this is called in C# is method overriding. This means that we had a method in our base class, which is shape. We marked it as virtual and instructed .NET that, hey, somebody that inherits from shape might want to override this and implement an own behavior. In this case, an own way to calculate the area of that specific geometric shape. And in the class that inherits from shape and where we want to change this behavior, we just need to use this override keyword, which will override the behavior of the method that we have in the base class. In this case, if we go back then to program.cs, we don't have to change anything here, and in this case, if you run this program, I would expect a correct result. So in this case, the square area is 49, which is correct. Here notice, please, this importance of this method override. How we achieve this, once again, in the base class, which is shape, we just marked the getArea method with virtual, and in the derived type, which is the square in this case that inherits from shape, we use this override keyword and indicate to .NET, hey, every time a square uses the getArea method, please use this implementation. In our case, please use this way to calculate the area. So everything is fine here. This is how basically we can use a base class and how we can override behavior in methods in our derived classes. So things are fairly easy in case of this class square. Let's go now one step further, because first we had a geometric shape that inherited from shape, which is rectangle, and in that case we just needed to provide the width and the height in the constructor and everything went well. Then we went one step further in this square class. This is a very particular class because we do not need both width and height, so we needed to work only with width. But to get the getArea method to work, we needed to mark it as virtual in the base class and override it using the override keyword in the derived class. And here we implemented a new getArea calculation, which would be width multiplied by width. Let's go right now one step further, and we can assume that we want also to implement another geometric shape, which is a triangle. So let's go back here, right click the project, add new class. Here this class would be called triangle.cs, of course. Now we have a new class. We can also mark it as public for now, public class triangle, and we can start working here. Now triangle is again very special, because in the case of this triangle we really don't have a width and, well, we do not have directly a height. But if we remember from geometry, the way we calculate the area for a triangle also uses a height. That is most probably an imaginary line from the top of the triangle to the base of the triangle, so that we have a 90-degree angle. This means that in order to calculate the area of a triangle, what we need is the base, and what we also need is the height. In this case, we can simply try to also add the constructor here. Let's make triangle also inherit from shape. We said that we need the height. Even if the height is not something that is directly defining a triangle, it is an imaginary line that we really need in order to calculate the area of the triangle. In this case, of course, we can provide this information, so what we can do is we need an integer for height. And what we would also need is an integer for base. Let's call it triangle base. Here in the constructor, of course, since we inherited, we can use height, the property from shape, and assign the value that we get from the constructor. So this would be it. For the base, however, we need once again something new. We would need a new property that is really specific for the triangle. In this case, it would also be an integer. This would be triangle base. Of course, we need the getter and the setter to fully declare a property. Here it is a very good example because triangle inherited from shape, so the height is from shape, but as we said, each derived type, each derived class can, however, of course, have its own properties. In this case, for triangle, we added a new property which is called triangle base. So in the constructor, we can go back, and triangle base would be equal to the value that we get from the constructor. So right now, when we construct a new triangle, we would have both height and triangle base specified. In this case, we can simply implement the getArea method. Of course, in this case, the calculation is a little bit different, so we don't have just to multiply this the width or the height, or to multiply the height by the height, or any of these combinations. So this means that we would need to implement also a new behavior for getArea. This is why we will override once again also in triangle the getArea method that we have in shape. So it would be public override, it would be a double, and we want to override getArea. And C# already did some things for us, but we really don't need this right now. So right now what we have here is a new override of the new getArea method. The red squiggly line is really no problem here because we do not return anything at this point, but we will return something very soon. If we remember correctly from the geometry classes, well, we calculate the area of a triangle by multiplying 0.5 or 1/2, multiplying with the base and multiply it by the height. This would be something like return 0.5 multiplied, and here we have the base. The base would be called triangle base here, multiplied by the height. So this would be the area of a triangle, if I recall correctly. Now if we go back to program.cs, we can simply also implement the triangle. So let's create a triangle. So triangle, let's name it T1 equals new triangle. And here for the triangle, I said we have to specify, let's check again, height and the triangle base. The height would be, we could have it 10, and the base could be, I don't know, let's make it once again 7. Now we can simply do a console write line, console.writeLine. Here what we will do is also use the exact same method. Here we will print the triangle area is. Here it would be T1, and since we have overridden the getArea method in the shape, when we use getArea here, it will use the triangle formula to calculate the area. So I would assume that when we run this program, also the triangle area is calculated correctly. Let's check it out, and indeed the triangle area is 35, which seems fair enough. Let's go, however, right now one step further. We want to create a new geometrical shape, and this would be a circle. Therefore, right-click the project, add, you already know the drill, new class. This would be called circle.cs, because this would be a circle. Let's make it public. Here there is a not necessary space. We can also implement the shape here. So we inherit from shape. In this case, circle is a derived class and shape is the base class. Circle is right now also a very specific geometric shape that has its own particularities. First of all, if we think about how we calculate the area of a circle, well, we do not have a height, we do not have a width, we do not have a triangle base, because we have a circle, obviously, and the circle, well, it's round. This means that we have one new thing here that is called radius. Let's define this as a property. So we have public int radius. We also need a getter and a setter to have a complete property. But one other thing that we need in order to calculate the area of a circle is a constant, which is the p constant. So you know that the p constant is 3.14 and so on. What we can do is here also declare and set the value of this constant. This would be public const double, let's call it p, and this would be 3.14. What I usually like to do is when I use constants in a class, I usually like to use only capital letters, so only uppercase letters. This is a way for me to know when I see this type of naming that, hey, this is surely a constant, and I have to look for the value somewhere. Either we define it here or we take it from a service, but we know, however, that this is a constant. Let's go one step further and use a constructor. Here in the constructor for the circle, we do not need a width and we do not also need a height, but we need a radius. Therefore, we would need an integer that will represent the radius. And of course, our property radius would be equal to what we receive from the constructor. So it's radius. This is okay. Right now, I can simply implement the getArea method. I can simply override it. So it will be public override. I have also to type it correctly. Override double getArea. Let's also delete here because we want to do our own implementation. And the area of the circle, if I recall correctly, is P or square radius. So this means that we would have to multiply P by radius and once again by radius. So this would be return. Our constant is P multiplied by radius and once again multiplied by radius. Of course, we could write it also another way to make it, let's say, more clear about how this is calculated, and we can put radius multiplied by radius in parentheses. However, we know that multiplication in this case should give us the same result. So it's no matter if you use parentheses or not, the result should be okay. Good, so now we have implemented our circle. If we go back to program.cs, we can simply put here a new circle. So we would have a circle, C1, new circle. We said that we need to provide a value for the radius, and this would be 8. Here we can then jump over and do a console write line. Here we would write the area or the circle area to be consistent is, and here we have c1.getArea. Since we have overridden this method, it will take the override that we have declared in the derived type, which was the circle, and I would expect a correct result. So let's run this application once again, and we have here the area for shape, for the rectangle, for the square, for the triangle, and also we have the area for the circle. So everything should be fine right now. Good. The reason why I wanted to use these geometric shapes is because once again we have a base class, which is this shape, that specifies a property width and a property height, and also a virtual method getArea that can be overridden. Then we have implemented a rectangle, which is very similar to the shape class that we have previously defined. So what we need to do, the only things that we needed to do is to provide or to give values to the properties from the arguments or parameters that we receive from the constructor. So in this case we set the width and the height, even if we do not need to define anything else on this rectangle class. And all our code still works. Then we went one step further to have a square, and the square is very interesting because it doesn't have necessarily a width and a height because they should be equal. So in our case, we wanted to only use the width. This means that from the shape base class, we have inherited only one property, and we have overridden the getArea method to recalculate the square area based on the knowledge that we have in the square class. Then we went one step further and we used this triangle class. In the triangle class, the interesting thing was that we still needed the height, but we already also needed a new triangle base. In this case, we used a new property. So even if triangle inherited shape with width and height, we can simply use only one of the inherited properties here, and we can extend our triangle class with its own properties. In our case, it would be triangle base. And of course, we have then overridden the getArea method to calculate the triangle area as a triangle area should be calculated. And last but not least, the last example was the circle. Here the very interesting thing is that we basically didn't use any of the properties that we inherited from shape. We have just overridden this getArea method to recalculate exactly how or to reflect exactly how the area of a circle should be calculated. We also or even added a constant here, which is this p constant, which is 3.14, and we use this in order to calculate the area. Once again, here important to notice that from rectangle, the first shape that we have used, where we have used all the properties and all the methods from our base class shape, to the circle, which was the last shape that we created, where we basically do not inherit, or we do not use we do not use the inherited properties. The only thing that we do is we simply overwrite the getArea method. So that's mostly it about inheritance. Now, I promised you, of course, that we will come back to this type of keywords, public, like public, private, protected, and so on. As discussed during the theory part, these are accessibility modifiers, and they specify if a certain property or method in a class should be available in another class. For instance, if we are here in this program.cs, this is the program class, so it's a totally separate class. And in shape, we see that this height property is available for us. Let's go now in the shape class and let's change this from public to private. In this case, we see that what we get are a lot of errors. If we go here, error list, we see that we have really a lot of errors. Because of course we cannot overwrite things anymore, since this information like width and height are now private. As stated during during the theory part, is that if we use this private keyword, this means that width and height, these properties would be available to be set or to be used only within this class. So only within this class definition. This means, of course, that we cannot simply do this string.width and string.height, even if height seems still to be available. Let's go back and check. Of course, because we haven't changed this, so let's also change this to private. Once again, if we go back right now in the program.cs, we simply cannot set these properties because they are not visible. And here we also get this message that height is inaccessible due to its protection level. So these access modifiers that we have used in this shape class basically said, hey, width and height are to be used only privately within this class. In this case, of course, that everything that we worked here breaks, because suddenly width and height are not available anymore. Let's change this now to protected. So once again, protected. What we will see right now is that there are a lot of, sorry, this can be still be public. Let's change this to protected. And right now, if we check back our errors, we see that, hey, suddenly we have only 2 errors. Why is this case? Let's first double click this error and check exactly what happens. And we see here that height and width are still not accessible here. But how comes that suddenly all other errors are gone? So when we are working in each of these classes, in a rectangle with width and height, or in square when we are working with width, or in triangle, basically we do not have any problems anymore. But only here in program.cs, when we try to do this, or when we try to assign a value to height and to width, it's still not possible. And if we hover the mouse, it's still exactly the same. So width is inaccessible due to its protection levels. And this is because what we said about protected. Protected means basically that if we define something as protected, like these 2 properties here, this means that these properties can be used inside this class definition. So here we do not have any other problems, but also in derived types. And rectangle is a derived type. So this means that in this case we can simply also use width and height. Square is also a derived type because it inherits shape. So this is why we can use this width. triangle also is a derived type because it inherits shape, and therefore we can use the triangle height. The only place basically where this is out of place, we can also say, is in program.cs, where we cannot use this because program does not inherit from shape. But if we would inherit from shape, let's check this out. Suddenly, of course, we would have also to implement things, but of course we have to set here a constructor for program with height and width, so of course that this is still not working. However, there is another keyword that I said it is very, very important, and that would be the internal keyword. Let's go back to shape.cs and let's change this from protected to internal. So this would be internal, and this would also be internal. Of course, we have to specify to not use any typos here, and suddenly we do not have any errors. So a miracle, everything worked just fine. Why did this happen? As said in the theory part, internal keyword indicates that those properties, or each members or any member that is marked with that internal keyword, is accessible to any class, so to any code within the same assembly. The assembly is of course the project. We said this earlier, I think it was in the second or third lesson already, when we debug or when we build a project, it results in a DLL file or in an exe file, and this is an assembly. And this basically means that if we mark something as internal, as long as as the class where we want to use these properties is inside the same project, we would be able to access it. But if we would have here a new project, because we said in one solution we could have several projects, if we would have here another project called my first app test, for instance, then these properties width and height wouldn't be available because it is in a new project, and therefore it means that we try to access those properties in a new assembly, and this is of course not possible. And as said, these four accessibility modifiers are the most important ones. So we have public. If we have public, everything is available anywhere basically. If we use private, it's the exact opposite of public. So those properties or members are available only within that exact class definition and nowhere outside of that. If we use protected, it means that those members are available for derived types and of course within the class definition. And then internal, which means that these members are available to all classes within this current assembly. So this is how access modifiers work. And a last thing that we saw here is when we use private, and this is also the magic of inheritance. If we change here this to private, even if we do not do any other changes to any other part of the code, we can see that we have this error because all derived types that work with this width suddenly are not able to work anymore. And therefore, of course, we would have to address some things here. Let's change this, however, back. So we can do this very easy. Let's make it internal once again. And the last thing to show here, if we want to add a new property, and we can think about that this property is maybe common to all the shapes. What property could this be? It would be, I don't know, let's make it also an int. We can make it public, or let's make it internal to play around with this. Internal int, and well, it would be let's say the value of the perimeter of the shape. So we call it like that. It's get set. Now the very cool thing about inheritance and the magic behind inheritance is that, well, if we would not inherit this and we would say, hey, we want to add this new property to all our shapes, this would mean that we would have to go in each class and then add this property. Still, in our case, if we go here in square or triangle, or let's go to rectangle. It's really not important right now, but this means that what we can do is simply we do not need to define that property once again. We would have an int for the perimeter, and of course we can set this value. Something is not quite okay. It is. So that's right. Once again, this means that we have to do this change only in the base class, and of course in the derived types, in the derived classes, we just have to use this property if we need to use it at all. For instance, well, in case of the circle, we could use it maybe. However, once again, important is that when you have inheritance in place, if you add a new property on the base class, it would be suddenly or immediately available to all derived types to work with it. So we do not have to go to each class and add this property. And here we have a very few geometric shapes, like I think there are 5 in total. But let's assume that we would maybe, like, I don't know, maybe work with 100 geometric shapes, also 3D shapes. If we want to add a new property that should be available for all shapes, or a new method, for instance, then we would have to go in each of those 100 classes and add the property or the method that we need. But with inheritance, we just have to specify it once, then we can use it in all derived types. If we need to override behavior, we can do that, but we do not have to manually write or define once again the same property and or the same method in all 100 potential classes that we would have if we would work with 100 different shapes. So that's mostly it about inheritance and access modifiers. In the next lesson we will go one step further, and it will be really the last lesson that kind of has something to do with classes, and it would be on interfaces. And after that, we'll surely switch a little bit, let's say, the key points on which we will concentrate during this course, and we will look a little bit deeper into some very interesting things like clients, readers, writers in C#. For instance, how you can write to a file, or how can you make an HTTP call, and other very interesting and very practical things. Thank you very much for watching this lesson, and I hope I will see you in the next lesson. And till the next time, I wish you the very best.